Quiz Prep, Chapter 4.1. Okay, here we are at Chapter 4.1 Quiz Prep. So let's read the scenario. So in the following data pairs, X equals the average salaries for males in $1,000 per year. So like 34 means 34,000. And Y is the average salaries for females at $1,000 per year for assistant professors at the same college or university. So that's the trick. The experimental unit here is the college or university, and the X and Y pairs are about each. So you've got the mean male salary, or the X, yeah, that's our that yeah mean male salary, and then the mean female salary at each of these colleges. So we have these colleges 1, 2, 3, 4, 5. We got 5 colleges, and then over here, wow, these are pretty low. I can guarantee you they're accurate. Okay, well anyway, so well, at least these female ones are. I don't know about the male ones because I'm not male. But in any case, these are, for each college we got the pair. And then we've got these A, B, C, D, we've got all this, and we got fill in the answers. And so if you're wondering, well, why do you want me to fill in this huge table? Well, we're moving on up to calculating like R. So in order to calculate R, we need to fill in this table. So let's get started. All right, so I transferred this over here so we could draw on it and we can start filling in it. So let's start with the first row, which is college A1 here, A1. So what are we going to have to fill in? We're going to have to fill in x to the second, y to the second, and x times y. Okay, I just pointed out all those. We can erase that. So how are we going to get x to the second, or a, right? Like cell A. So, well, here's x, right? So what is that going to be? It's going to be 34.50 times 34.50, right? Which equals 1190.3. Okay, so that equals A. So this one right here, that's what you would do. You would do x to the second. Okay, this is so big. I don't need all this here. So you see how easy that was? We just took 34.50 times itself. Well, now let's do y to the second, right? Here I got y to the second. So what is that going to be? Well, where's our y? It's over here. Here's our y. So that's 33.90. So we're going to do 33.90 to the second, right, which is exactly the same as times 3.90. And then what does that equal, right? Well, that equals whatever f is. So f is, see, that's this one we're doing. That's 1149.2. Okay. Yeah, so this is pretty tedious to fill in, but you kind of need to do it. Otherwise, you're not going to be able to calculate R, because this is sort of on your way to calculating R. So what is XY? What's this last one here? How do you, I keep doing this here. So how do you get to XY? Well, it's a little like x to the second and y to the second, only you just take just the x. Remember, for A1, it's 34.50 times, and the y is 33.90. And that's going to equal whatever we put for k, which is 1169.6. Okay, so you get what's going on here, and that's what's going to go in here for k. So what's going on here is, to do this one, you just take each one of these and you times it by itself, right? Then to do this one, you take each one of these and you times it by itself. Then finally, to do this one, you times the first one by the second one. So why don't you do all that, and then we'll come back and I'll show you what the answers are. Alright, so here we go. We have actually filled in all of these things, right? So I'm going to just tell you a little cheat to get ahead. Okay, so the whole reason we filled in the stupid table was to actually get the totals at the bottom, right? So we're going to want, I mean, the whole point of this was to get the sum of x squared, which will be down here, this total. And then we'll get the sum of y squared, which will be this total down here. And then we'll also get the sum of x, y, which will be this total down here. So you can work ahead if you want. You know, before we go on and do R, we really need to plot these XY pairs in a scatter plot because it'll help guide us to help us make sure that we're doing R right. So here we go. I set up our blank scatter plot over here. So as you can see on the x-axis, this is x, because remember y is kind of like this long y. So that's how I remember that the y-axis is the up and down one. So the cross one is the x-axis. So that's why I put this male professors on the x, and then here's the female professors. That's why I put that on the y. Okay, so now we know what we're doing, and now we just have to plot it. So let's start with A1. So the male professors, they're over at 34.5. So that's about here. That's on the x. And then how far do we go up? We go up to 33.9 for the y. So what's 33.9? That's almost 44. So let's put a little dot right there, right? Okay, let's do B1. Okay, so 30.5. Oh, that's way down here, right? That's what the men make. And 31.2 is what the women make. So we'll go up here and there. There we got two dots. Let's see. C1, that's 35.1. So it's 35. This is almost here. So let's go up then to 35, which is for women over here. Moving on to D1, 35.7. That's really kind of close. 35.7 maybe is over here. And then 34.2 for women. So that's maybe over here. Right? And then the last one is 31.5, so that's probably in here somewhere. And then 32.4, that's about up here. So as you can see, you know, I'm just going to point this out here. You've got, you know, these are the points, and you can kind of see it goes up a little bit, right? It sort of has this upward trend. So when the male salary is high, the women's salary is high, and when the male salary is low is women's salary is low. So because it's doing that, you think that R is going to be positive. If it was going the other way, like this, then you would think that R is going to be negative. So that's why you want to plot all this before you go too far. And of course, let's look at the actual question. So it says, the actual question says, whoops, select the scattergram that plots the data correctly. Well, let's take a look here. Which is the one? Well, we certainly didn't see this pattern here, where we've got this, this one, we didn't have a high one like that. We didn't really have, this is kind of, you know, straight across. We certainly didn't have this one going down. This certainly looks like the one that we had, right? Isn't that what we had? So therefore, this first one, A, is correct. Okay? All right, here we are. So we're all ready to calculate R. On the left side, we have the ingredients for R here. And on the right side, we have the huge, ugly R formula. Now, before we do this, I just want to remind you, why are we calculating R? Remember at the beginning, we had 5 experimental units. You can have as many as you want. And ours were colleges. Now, each of these units had 2 attributes. They had an X and a Y. Okay, and the X was male professor salaries and Y was female professor salaries. And the whole question was, we wanted to produce a number, which we're going to call R, that talks about whether or not, first of all, if the male salaries go up, the female ones go up too, or if the male salaries go down, the female ones go up, which would be an inverse correlation, or if the male salaries go up, it doesn't really matter, like the female salaries do whatever they want. in which case there really isn't a correlation. So we're looking for that, and this number is going to help us. And actually, let me just explain Monika's strategy for interpreting R. So R is always going to be, it's going to be the lowest your R can be is -1, right? That's the lowest. And that's if you go like down like that, right? So if you've got a downward one, your R is going to be between -1 and 0. Okay? But if you got, here, let's use any excuse to use more color. So if you got an upward one, right, like which is the one we saw, so this is what we're going to expect, then our R is going to go between 0 and 1. Okay? Now, the more correlated they are, like in algebra, if they're right on the line, like if this is right on the line, and if this is right on the line, then it would be the actual one. So if it was right on the line, that would be this one, and if it's right on the line, it would be this one. So that's a good way of remembering that the more correlated they are, the closer they are to 1. So when it comes to, positive correlation, I always say that if you go from 0, which is no correlation, to about 0.3, I say that's low. And if you go from like 0.3 to 0.7, that's medium. And if you go from 0.7 to 1.0, which is this one is 1.0, right there, then that's high, or strong. You see what I'm saying? All right, and then for the negative version, really into red, it would be from 0 to -3, and from negative 0.3, -0.3 to -0.7, and -0.7 to -1, because remember that's the negative. So that's how you interpret R. So I'm just getting you set up for this. Like once we actually calculate this thing, what we're going to come up with is, okay, we're going to have some number between 0 and well, we already sort of ruled this out because we saw the scatter plot. It's not going to go down. It's going to go up. And so we're going to have a number between like 0 and +1. And if it's closer to 0, there's closer to nothing going on. It like doesn't matter how much men get paid. Women get paid a different amount. It doesn't matter. All the way up to this one here, which is, well, if men go up, women go up. Okay, so we're going to calculate R, and we're going to see what category it falls in here. Okay, now we're actually going to get down to calculating R. On the left side, you'll see this is the answer to question 2, but you can see it's just the, except for N at the top, which is, you count up the 5, it's just the column totals. And that's why we made that table in the beginning part of this quiz prep, is so we can get these totals. So now we have these totals so we can calculate R, which is on the right side. So what I do is I always start, so this thing at the top is called the numerator, and this thing is called the denominator. Whenever you have a fraction, you have that. So each thing in there, like this is a thing, this is a thing, this is a thing, each blob is called a term. So what I do is I just kind of calculate these terms separately, and then I put them all together. And I usually start with the numerator. So let's start with the first term in the first numerator. So we have n sum of xy. Oops. So I'm going to fill that in a different color. I'm going to put the real one. So n was 5, right? And then we mean times, because this is right next to it. And that's 5591.2. So that would be your first term. Okay, I'll put that there. So going back to the formula, we're still looking at the numerator, and the next thing it says is, I'm just rewriting this, sum of x times the sum of y. And I just want to make you notice order of operation stuff. I guess this is going to be green. That's not a very pleasant color, but you have to do that term, and then you have to do that term before you do the minus thing, because the first things are multiply, and then the minus thing is minus. So remember, multiply and divide come before minus and plus. So I just want to throw that in there. Some of you do a lot of algebra and some of you don't, so I just want to remind you. All right, so then we're going to do minus, and then we're going to fill in the sum of x and sum of y, which is, look at that, 167.3, and that's going to be times 166.7. You see where I'm getting this stuff? Okay, well, now let's keep working this out because I actually worked this out. I actually did both of those terms, so let me see if I can, let's see here. This one came out to be 27,956.0. I'm just being accurate here. And then this one came out to be 27,888.9. And if you actually work this out, do this minus thing, you get equals 67.1, which I'm going to just put up here because that's our numerator, remember? It's 67, and this is actually easier than the denominator. Okay, so we got that. So now I'm going to actually just erase all this because it's in the way. And now let's get started on the denominator. So what's kind of big about this is we've got this huge square root thing. Whoops. This huge square root thing that we're going to have to put over the whole thing, but over each term. See, there's a term here with a square root thing over it, and a term here with a square root thing over it. But let's just take things one at a time here. Let's actually just take, you see there's two terms, right? Let's take the first term. And let's just not worry about the square root until the end of the first term, okay? So our first term is going to be n, and then you have square root of x to the second. I'm sorry, sum of x to the second. And then minus, I'm just copying the formula. Sum of x, to the second. See that? That 2 is on the outside. Well, let's just revisit what does that mean, okay? This is how I remember what this means. Is I remember the rule of do the stuff in parentheses first, okay? So let's say that I'm walking down the street and I encounter this and I see do the stuff in parentheses first. I always get confused. So I think, well, what if this actually was the opposite? What if it was like this? Then I'd do the stuff in parentheses first, and what would the stuff in parentheses be? It would be summing up all the x's. It would be this one here. Okay, but if I don't do the stuff, like if it's in here, then it means I've got to do the x to the second before summing it. So I'm talking actually about this. So the bottom line is do the stuff in parentheses first, and that will help you remember which one of these you want, the B one or the D one up there. Okay, so let's just get rid of that. I just want to do that little side note here. Okay, so that's our first term. We will take purple here to fill it in. Our first term before the little square rooty deal. So I'm going to fill that in. So that's going to be 5. And then what do we have? We have in parentheses. So we decided this is going to be what's in here, right? And so let me see if I can even rewrite it right. 5619.4. Okay? Minus, and then what goes in the parentheses is, like we said, B. 167.3 to the second. Okay, and remember, order of operation means we have to do each side of this separately. Okay, and then we have to square root it, right? Okay, so I actually did out like the whole first term, right? This whole square rooted thing, and that whole thing came out to 10.4, right? After the square root. So you got to do this one, you got to do this one, so the second, minus whatever you get here from whatever you get here, and then take the square root, and you should get 10.4. So I'm going to just write that, maybe I'll put it in blue so I remember it. So this first term is going to be 10.4. Okay, now let's work on the second term. Let's just erase all this. But you can kind of see it's just a matter of doing a lot of math, basically. I'm not that good at math. Oh, all right. So the second term, actually, let's use red. So the second one is the square root, technically, we'll do that last, of um, sum of y squared minus sum of y. Well, this doesn't really surprise us because we haven't done the y's yet. So let's redo this. So this is supposed to be the 5 times. So which one is this going to be? This is going to be e, what's over here, right, in e. So that's going to be 5, 5, 6, 7, minus, and then we've got the sum of y, that's 166.7, and then we got to square root it. All right, we're getting close here. Now we just need to do the math and for the second term. So let's, so just to remind you, we got to do this one first, and then do this one, and then minus this one from this one, and then do the square root to get the second term. That's even just the second term. We already did one term. Okay, so to just let you know what I ended up with for the second term, you can do that yourself because I'm probably screw it up actually, was 6.8. And that actually goes over here, 6.8. And then you end up with a little star there, right? Because this whole thing times this whole thing. That's what we just did. All right. Now I'm going to tell you that if you do this out, you get 70.7. Now we've simply reduced r to this fraction, and then if you do the fraction off, let's see, or maybe I'll go back to red. So you've got the numerator up here divided by the denominator down here, and you get 0.95. Okay, so that's r. That was this whole business was about r. We used all of these, we put it in there, and we got that. Now I just want to remind you, we were looking for a positive r, and we saw one, right, because our scatter plot was going up. And we were looking for a r that went up a lot, right? And remember, this is close to 1.0. Okay, so so we got to r. How about that? Okay, well, let's bring it back to the actual quiz prep that we're doing. So we have question 4, and now, you know, we answered it, right? 0.95. We just have 2 more questions. Is the correlation strong or weak? Well, remember my little scheme of 0 to 0.3 was weak, and then and this is just my opinion. Like, I actually asked someone who is an expert more than me, and this, he told me this, but he said it was just his opinion. So I guess we're just passing around this opinion. You know, so I go up to 0.7. Well, obviously this one is huge, right? So we know that it is strong. So that's the answer to 5. Finally, is the correlation positive or negative? Well, we have 2 ways of seeing it. One is we saw the scatter plot, it was going up and not down, so that's positive. Also, this r is literally positive, so the answer is positive. So good job, you calculated r. Now you're all ready for the quiz. Good luck.